Okay, so we are about to move on. We've been talking about categorical data, and we're about to move on to quantitative data, and we're going to use calculating some basic measures of center and spread, and you're going to need your calculator for this. All right. So when we were discussing qualitative or categorical data, these describe attributes: gender, color, ethnicity, physical condition, whether you're good shape or bad shape, and many other things. And while we also recognize that qualitative data may be non-numerical, and that order or is non-numerical, and that order doesn't matter. However, sometimes we assign numbers for coding purposes, such as a UPC product code or a social security number. Your social security number has no order, doesn't say that you're first or last, or it's not even related to when you were born. Or whether we give girls a 1 and we code guys as a 0. And we wouldn't, and in those cases, even though we assign numerical values, we're not going to take an average of the social security numbers, but we're not going to take an average of the 0 for the guys and the 1 for the girls. So we can't talk about mean or median or range. And I mean, if you took the average of 0 and 1, you get 0.5, and that's not a, that just doesn't make sense in the situation that we're talking about. So we can't use numerical values for categorical, or we can't talk about measures of center and spread when we're talking about categorical. But when we go to quantitative, when we talk about, we can talk about things like height and weight, number of pets, etc. And in this case, order does matter. All right, type of pet wouldn't matter, but the number of pets would be in order. Consider your class rank. Obviously, we care about order, especially the top 10%, or how much someone can lift, or how fast you are, how much money you make. I should say earn, because we're not going to print the money. In these cases, order absolutely does matter. Of course, because you need some more definition to contend with, quantitative data can be divided into 2 separate groups, which we talked about earlier: discrete and continuous. Discrete is quantitative data that can be counted, the number of people, the number of students with blue eyes, whereas continuous is data that takes on any fractional or decimal value. Okay, so as we work with this, let's go to our calculators and learn how to input some data. So when I go through this, I need to check something real quickly. Awesome, great, it's working the way it's supposed to. I'm going to go to my calculator, and the very first thing I'm going to go to is I'm going to go to the, hold on a second. First off, I need to turn my calculator on, so I'm going to find the on button down at the bottom. Press that, turn the calculator on. And I don't know what you have on the screen, but let's just say you had a bunch of gibberish. Go ahead and press clear, which is right here. And I'm going to go ahead and say press mode. And we're going to scroll way down, because there's something you should make sure that it's turned on, because it'll help you. All right, first off, where it says stat diagnostics, I want to arrow over and turn that on. So it's all right, so turn that on. And Stat Wizards is already on, and I think that's cool. I want to be a Stat Wizard someday. Maybe I already am doing that in hiding, but make sure that's on. All right. Once that's on, you can just press the second button here, and this is quit, second quit. Press clear, we have a clear screen. Now, one of the screens that we're going to use a whole lot is the stat screen. Now, stat edit should be highlighted, and I'm going to press the enter button. And it turns out in mine, I have a bunch of stuff, and that's oftentimes a real pain. So you just press the arrow up, press clear, and then press enter. And I can do arrow over, clear, press enter, clear, press enter. All right, so now I have everything cleared out, and I'm going to take a moment, and I'm going to enter this data. So 9, enter, 8, enter. I shouldn't cover this up. 7 enter, 6 enter, 5 enter, 4 enter, 3 enter, 2 enter, 1 enter, -10 enter. So I have it all entered. And basically we're going to take the average. You're like, I could have taken the average and added it all up myself. Yes, you could have. All right, I recognize that. So now that I have it in there, I'm going to press stat. I'm going to arrow over to calc. One variable statistics needs to be highlighted. And by the way, these commands right here, I'm going to press enter. And I don't know what yours says. So just in case it doesn't say what it's supposed to, press the second button, followed by the number 1. So it says L1. Right now, we don't have to worry about the frequency. And we got a bunch of information. Now, what is that information? Well, X bar is the mean or the average. 35 is what happens if you add everything up. So if I add these values up, they're going to sum up to 35. How many values did I input? This is 10. That's my sample size. Then I have a minimum value of -10. Quart Q1 is 2. The middlemost value is 4.5 when I put them in order from least to greatest. This is a 75th value, or Q3. And my maximum value is 9. Now, a couple things I skipped. I have SX, and this is also, which stands for standard deviation. That's standard deviation of the sample. This is standard deviation of the population. And notice they're close, but not exactly the same. So if this is the entire population of values, I would have gotten 5.4. But if this is only a subset of a larger population, or this is the sample, my sample statistic would be, I said that wrong. If this is the entire population, my standard deviation would be 5.12. But if this is only a subset from the population, my standard deviation is 5.4. Okay, so let's look at some formulas. So we're still working with that same data right here that we entered. And my formulas are the sum of all the x's divided by 10. This mu stands for a population. This is a population parameter. So this x bar that we got here, all right, so this is the population parameter, which is 3.5. Now, if this is just a sample, we would use x bar. So this is a population. This is the parameter. This is a sample, and it's a statistic. Okay. All right. Well, the median is the middlemost value when you line them up least to greatest. Well, I line them up least to greatest, and I go, then I'm going to strike them off, just like you've done before. And I ended up with 4 and 5 as being my middle two values. So 4 plus 5 divided by 2, 9 divided by 2 is 4.5. Just take the average of the two. Now, there's the problem with when you use which. Well, the mean is impacted by outliers and non-symmetric data. So it's not very good if we have outliers and non-symmetric data. That -10 had a great impact. However, the median is not impacted by outliers or non-symmetric data. So if we have non-symmetric data or outliers, we probably should be using the median. We will take a look at that in greater detail in a moment in the next grouping of videos, but right now, just kind of getting some definitions lined out. Now, one thing I'll say about how do you figure? Well, let's just say that you had 9 100s and then you got a 0. Well, that 0 is an outlier, and then pull your grade way down. Your average would drop from an A from a 100 to like an 89. On the other hand, or to 90. On the other hand, what happens with the median? Well, the median say take the middlemost value, and the middlemost value in that case of 9 100s and then a 0 is a 100. So guys, you really should be talking to your teacher and say, I want you to use the median for my average, for my grade, not my average. Because like I said, the outliers and non-symmetric data really impact the mean, but they don't have much impact on the median. I should say one other thing though. Most of the time we use the mean, but you are going to need to know about median as well. Range. Range is something you've talked about before, and it's the distance between the largest and the smallest value. It's a singular value. All right. In this case, our largest value was a 9, and our smallest value was a -10. So 9 minus a -10 is 19. So our range is 19. Okay. Then we get into this thing called the IQR, or interquartile range. All right. Well, the calculator did that for us. Remember, if I scroll down, it gives us Q1 and Q3. The interquartile range is awesome because it's not impacted by outliers. Obviously, the range is very impacted by outliers. And it's very impacted by outliers because it includes the lowest and the highest. So it's obviously, if there's an outlier, it's going to be impacted by it because it uses it. This is the middle 50%. IQR, interquartile range, is the middle 50%. And it's the 75th percentile minus the 25th percentile. And basically all you do is take Q3 minus Q1. Well, we said Q3 was 7. We said Q1 was 2. And 7 minus 2 is 5. All right. So the range of the middle 50%, the range of the middle 50% happens to be 5. Again, it's a singular value, but you need to memorize this formula. This formula is not on the formula chart. That formula is not on the formula chart. So Q3 minus Q1, and you will use that a lot, okay? Standard deviation. Not going to have to use this very much, and it does show up on the formula chart, but we'll take a look at it. And it's the average distance each of the data points is from the mean. Well, we calculated the mean as 3.5. So I'm going to take each individual data point and subtract it. Okay. So my -10 minus 3.5, 1 minus 3.5, all the way across for all of them. All right. And then I divide by 10. Why 10? Because that was my sample size. Now you're probably going, why did you square them? Well, if I don't, it could sum up to 0 because I have some values below, some values above, so it should sum up to 0. So this is why I have to square them. But since I squared them when I added them, I have to take the square root of them. So that ends up giving me that 5.1234 that we calculate for the population. All right. Rarely going to have to show the work for this, but the calculator does it quite nicely for you. So that's how you enter the data in the calculator. So once again, stat, edit, enter the data, stat, calc, one variable statistics, second button followed by the number 1, press enter. You'll get everything. There's my median at 4.5. So you get all the values. Very nice, very quick, very easy to do. Just need to practice it a couple of times.